Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Even Distribution by Jonesy, and here are the rules. Hello, hi. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region. Orthogonally adjacent cells may not both contain even digits. So no even digits can share an edge with another even digit. Interesting. That's what orthogonally adjacent cells are. Just basically cells that share an edge. So these two cells cannot both contain even digits. It can be one even digit and one odd digit, or two odd digits. Those are both valid. But you cannot have two even digits sharing an edge together. Digits in a cage do not repeat and sum to the total given in the top left corner of the cage. So, for example, if this were, say, a 3 here, this would have to be 7, because these two digits must add up to 10. Because they have a 10 in the top right corner. And we have digits separated by a black dot have a 2-to-1 ratio. So, for example, if this were, say, a 3, this would have to be a 6 because they must be in a 1-to-2 ratio between them. Have fun. We will try. Anyways, those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, so normally, for a black Kropki dot, you could have the ratios be 1, 2, 2, 4, 3, 6, or 4, 8. But since no cells that share an edge with each other can both be even, that eliminates 2, 4 and 4, 8 to be in a 1-to-2 ratio. Also, if you have two 10s, or two digits adding up to 10, they must either be both even or both odd. And since both evens would violate the no orthogonally adjacent cells can contain two even digits, these must both be odd to add up to 10. So these are both odd and these are both odd. Since this is an odd here, this must be an even here to be in a 1-to-2 ratio. So this is guaranteed to be 1 or 3, and it must be with 2 or 6 there. So it's 7 or 9 to be odd there. Since this is even, none of these can be even, so these have to be odd digits here. Adding up to 15 can only be 6, 9, or 7, 8. Well, 7 or 9 cannot be in a 1-to-2 ratio with another digit, so this must be even here, and it's 6 or 8, which must not share an edge with an even digit, so these are all odd. So 6 or 8, 8 cannot be there because 8 would be in a 1-to-2 ratio only with 4, which is an even digit. So this must be 6, and this is 3 there. So 6 and 9 add up to 15, which means this can't be 6 or 9. It's 7 or 8 as a pair. This is 3 guaranteed here. Remaining digits in column 5 have to be 1 through 5. Again, we can't have 4 here. We can't have 3 or 5 there because the only digits which can be next to a black Kropki dot in this puzzle is 1, 2, and 3 and 6. So this is a 1, 2, 3, 6 triplet. This can't be 3, so therefore this can't be 6 because of 3 in the column. These can't be 3. This has to be an odd digit, so it can't be 2 or 4. Well, we have a 1, 2, 3, 6 quadruplet in row 5, which eliminates 1, 2, 3, and 6 in the rest of the row. So this is 4 or 5 there. 1, 2, or 3 is next to 1, 2, 3. It can't be 3 there because 3 can only be next to 6, so it's 1, 2, or 6 there. Hmm. So where is 3 in column 5? It has to be one of these digits there. Hmm. What else do we have? The rest of this adds up to 22. Does that really help us any? Not particularly. Remaining digits in row 5. We have 4, 5, 7, 8, 9. Not too helpful there. If this were odd, the problem is we have 3 evens left in this box, and they would have to share an edge. Yeah, we have 3 evens left in this box. If this were odd, the problem is you'd have to have 3 evens out of these 4, so therefore the 2 evens would have to share an edge somewhere. So this cannot be odd. It has to be even, which means these cells have to be odd. That forces both of these to be even here. And to add up to an odd sum, these are 3 evens. This is an odd sum. So right now, these 4 as a total is odd. So odd plus an even adds up to an odd sum. So this must be even, which means none of these can be even here, so those are odd. Okay. We have 3 more evens in box 2, or this upper central box. I should not call it box 2 because it's confusing for some people if I don't explain it, and I'd rather not explain it because it takes a while to explain. Anyways, if we have to have 3 evens here, if this were even, the problem is one of these would be guaranteed to be even here. So this cannot be even, this must be odd, which forces all 3 of these to be even. We have 2 more evens in row 1, and they cannot be sharing an edge with each other. So therefore, this can't be even, this must be odd. So that's even here and even here, which means these must be odd here. We have 5 odds in row 2. This can't be odd, therefore that's even. This can't be even because we have an even there. So this is odd. One of these is going to be odd. These 3 right now are all odd. That adds up to an odd sum, which plus that means this must be even as a sum here. To add up to even, you must be even or odd and odd. And if we had even here, they would share an edge, which is not allowed. So these are both odd, which forces this to be an even cell remaining in row 3. So this has to be 1, 5, 7, 9, guaranteed, to add up to 25 here. One of these, so this can't be even, so this is odd because they share an edge. We have 5 odds in row 4, which eliminates odds in the rest of the row. So these all must be even. That means these can't be even. They have to all be odd here. So this can't be 2 or 6. It's 1, which must be next to an even to be in a 1 to 2 ratio. So that's 2. This has to be odd. Cannot be 1 and 2. So it must be 3, which makes that a 6 there. So that's even there. Okay. This can't be even. This can't be even because they share an edge with an even cell. 4 evens here. We have 2 more evens in column 7. They cannot share an edge with each other, so they must be surrounding this odd digit here. So we have even here, even here. Therefore, these are all odd because they can't share an edge. We have 1, 2, 3, 4, 5 odds in column 8, which eliminates 5 odds in the rest of the column. So these are even. Again, this can't be 4 or 8. We have 3 evens surrounding in this sum, which adds up to an odd sum. This is odd, so therefore the last digit here must be even. That forces both of these to be odd. That leaves an even digit there. Can't be 5, 7, or 9. It's 4 and 8. We have 1, 2, 3, 4, 5 odds in column 6, so the rest are even. That means these must be odd here. Odd here. To add up to 15 again, you'd have to have an even there. That leaves this as odd. In row 6, we cannot have 2 evens here. So one of these is even, which means one of them must be odd, which gives us 5 odds in row 6. So this can't be odd. This is even. That leaves the remaining digit in this box as an odd digit because we have 4 evens in the box. That makes this a 5, so there's no 5 here. This can't be even, so no 5 here, no 4, 8. That leaves the remaining digit in row 5 as an even. That means this can't be even because it shares an edge. We have 3 evens in box 4. We have 5 odds. Oh, in this left central box. I keep getting used to that too much, probably. This is even then because of the 5 odds in the box. This has to be 4 and 8. This cannot be even because of the even digit in the column that shares an edge with it. We have 3 odd digits here. Again, these 2 digits must be even to add up to an odd sum, with the odd sum for these 3 digits, but it cannot be even, so it must be 2 odds. Which means we have 5 odds in column 3, so the remaining digit is even. That makes this not even here. This is odd. This is a 1 to 2 ratio, and this is odd, so this has to be even there. We have 5 odds in this lower central box, so this must be even. We have 5 odds in row 9, so this can't be odd. This is even. That can't be next to an edge with an odd digit. And we have 5 odd digits in this lower left-hand box, so the rest are even. So this has to be 1 or 3 here. 3 cannot be here because that's an even digit. So whereas 3 has to be here, which is in a 1 to 2 ratio with 6. This is even, so it must be 8, which makes that a 7. 5 eliminates 5 here, so that's a 1. This can't be 1 or 5. This can't be 1, 3, or 5 here because of their even digits. 1 eliminates 1 here because of 1 in the row. This adds up to 25 with 4 even digits, so it must be 2, 4, 6, 8. 6 cannot be here, 6 cannot be here. Where is 6 in this cage? It has to be here, so it's 2, 4, 6, 8 plus 5, adding up to 25. 6 eliminates 6 here. 6 eliminates 6 here, so this is 2, which is in a 1 to 2 ratio with 1. So that makes us 1 and 9. 2 eliminates 2 here, so it's 4 and 2 there. 5 eliminates 5 in the rest of the row. Also, these can't be 2 because of 2 in the box, so this is 4, 8 as a pair. That means this has to be 2 here. That leaves this as a 4, 8 pair in this left central box, and we have a 4, 8 pair in column 1. So that remaining digits in column 1 that are even are 2 and 6. This can't be 2 because of 2 in the row. So this is 6, which makes this 2. We have 2, 6, and 8 here. That leaves that as a 4. This can't be 4, 6, or 2, so that makes this 8, which makes this 4. That leaves the remaining even digit in the box as a 4. 4 eliminates 4 here, so that's 8, which makes this 4, which makes that 8. Last remaining even digit in row 3 is a 2. 8 eliminates 8 in the rest of row 5, so that's a 4. We have 6, 8 as a pair remaining in the even digits in row 1. That leaves this as a 4. We have 2, 8 remaining as the even digits in row 2. We have 6, 8 remaining in the digits in this right central box for even. That leaves a 2 remaining in column 8. This has to be a 4, 6 pair here because we have a 2 and 8 in the row. This can't be 4 because of 4 in the column, so that's 6, that's 4, which makes this an 8. 8 eliminates 8 here, so it's 6 and 8. We have 8 4s. We know where the last 4 has to be. It has to be there. This has to be 6 or 8 here. We have 2, 6, or 8 here, and this is 2 or 8 there. This 6 eliminates 6 in the rest of the cage, so this must be 8, and it has to be 5 to add up with 2, 4, 6, 8 to add up to 25. 8 eliminates 8 here, so it's 6, which makes this 8. 8 eliminates 8 here, so it's 2 and 8. 8 eliminates 8 here, so it's 2 and 6. We have a guaranteed, so this must be 1, 3, 5, 7, 9 here. 5 cannot be here. No 5 here. This can't, okay, this can't be 1 here. So remaining digits in row 3 are 1, 7, 9. We are guaranteed a 1 here, so that eliminates 1 in the rest of the cage. So this can't be 1 there. 5 has to be one of these two. This can't be 7 because of 7 in the row. This can't be 1 because of 1 in the column. And this has to be 3, 7, or 9. We are guaranteed in column 2 a 3 in one of these two cells. That eliminates 3 in the rest of the box. 3 also cannot be here because of 3 in the box. Whereas 9 in this upper central box cannot be here anymore because of 9 in the row, so 9 has to be there. Therefore, this becomes a 1, 7 pair, which eliminates 1 and 7 in the rest of the cage. So this can't be 7, this is 5, this can't be 7 or 5, it's 9. Okay. 5 in this upper right-hand box cannot be here or here, so it must be here. That leaves this as a 3, which means this is a 5, 7 pair remaining in row 1. 9 eliminates 9 here in column 4. Remaining digits, so this can't be 1, 3, or 5 here because of 1, 3 in the column and 5 in the row, so this must be 7 or 9. Well, we have a 1, 7, 9 triplet in row 7, which eliminates 1, 7, 9 in the rest of the row, so this can't be 7 or 9, it's 3. That eliminates 3 in the rest of the cage and box. Okay. Remaining digits in row 4. Actually, let's do row 2. We have 3 and 7. In row 4, it's 1, 3, 7. Okay. Um, hmm. Row. Do we have anything? Oh, these two add up to 10. This has to be 1, 7, or 9, so this must be 1, 9, or 3 here. We have a guaranteed 7 or 9 here, and this is 7 or 9. That eliminates 7 and 9 in the rest of the row. And where is the 3 possible? In row 9. Cannot be here because 3 is in the boxes. Can't be here because 3 is in the column, so this must be 3 here. So this is 3, which makes this 7. That's 3 in the corner. We celebrate because we're close to solving it. 7 eliminates 7 here, so that's 9, which makes this 7. It also eliminates 7 there, so that's 9. 7 eliminates 7 here, so it's 1 and 7 there. 9 eliminates 9 in the rest of the box, so we have a 1-7 pair now in row 7, and in that cage, which eliminates 1 and 7 in the rest of the cage. This can't be 1 or 7, it's 5. This can't be 1 or 5, it's 9. And 1 and 7 eliminates 7 there, so that's 9. That means the rest of row 9 is 1 and 5. This can't be 1 because of 1 in the column, so that's 5. That's 1, which eliminates 1 there, so it's 7 and 1 there. 7 eliminates 7 here, so it's 5 and 7. 1 eliminates 1 in the rest of the column. The last remaining odd digit in this lower left-hand box is a 7. 7 eliminates 7 in the rest of the column, so this is 3, which makes this 7. 7 eliminates 7 here, so it's 3. This can't be 3 or 7, it's 1. That leaves the remaining odd digit in column 1 as a 5. 1 and 3 eliminate 1 and 3 here, so that's 7. We have remaining in row 6, a 1 and a 3. This can't be 3 because of 3 in the column, so this is 1, that's 3. That leaves that as a 1, and that as a 9. And that's how you solve it. Yeah, pretty straightforward, especially with the no orthogonally adjacent cells can both contain even digits. It's a very restrictive rule set for that. So it definitely narrowed down how you had to approach this. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.